So here we have the serious talk of the evening, the science of Santa. I'm hoping, given that I have talked about moon landings being hoaxed, I have talked about UFOs not being extraterrestrial spacecraft, I'm hoping not to make any enemies this evening because I don't want to receive hate mail from 7-year-olds tomorrow morning. So we'll see how this goes. So, is Santa compatible with the laws of physics? The basic question I'm trying to answer is, just how many laws of physics does Santa actually break? And hence we can then conclude the likelihood of the existence or otherwise of Santa. So, as I'm sure we all know, Santa is allegedly a portly, jolly fellow with a white beard and a penchant for wearing red suits. Now, that in itself, although questionable fashion sense, does not mean that he can't exist. What about the claims that are made regarding his rather incredible feats? That's what we really want to look at. So, allegedly, Santa visits all households on Christmas Eve to deliver presents to all qualifying children. And what we mean by qualifying children, well, that's defined by his naughty and nice list, of course. Can we reconcile these incredible feats attributed to Santa with our understanding of science? And in particular, can we use any of the science described in other talks that I have given? I figured rather than just pluck things from the thin air, I would use some of the talks that I have given. One in the top right there, very recently. Others I have given to Southport U3A, and perhaps a few of those I haven't. So this is just about half of the talks that I've given, and I'm going to ask myself, is there anything in any of those that help us understand whether or not Santa breaks any laws of physics? So let's firstly remind ourselves of what it is that we're dealing with. This is the statement that I'm going to unpick, the statement that Santa visits households on Christmas Eve to deliver presents to children. And I'm going to try and take each of the elements of that particular sentence and see if any of them unravel when we start to apply some scientific logic. So firstly, we're just going to make sure we know how many children we're talking about. So firstly, how many? Well, the Earth population, these are very rough figures. Don't start assuming that I'm doing anything accurately here. Earth population is getting on for 8 billion people. About a quarter of them are children, and about half of the Earth's population are eligible for Christmas presents. That means either Christianity or no assigned religion. And so, given that Santa will deliver Christmas presents even if it's not labelled as a Christian household, that means about half of the world. Half of the world and about a quarter of that are children, so that means about 1 billion children get Christmas presents. Let's assume, for the sake of argument, the naughty list is empty and everybody is on the nice list. So about 1 billion, I don't care if that's off by 10 or 20 or 30%, let's just use ballpark figures. So 1 billion places have to be visited. So the statement is that Santa visits these various places. How many children per household? Well, statistics vary, but it's not actually that much different from one when you average over the entire world. So 1 billion children equates to, roughly speaking, 1 billion households. So how does he actually get from one household to the next? So one statement we can ask is, can reindeer fly? Well, insects fly, and birds fly, and pterosaurs fly, pterosaurs being pteranodons or pterodactyls. You don't see them much these days, they seem to be getting very unpopular, but of course, as well as all of those, some mammals fly as well. So a lot of the animal kingdom flies. If reindeer can fly, well, they choose not to do so for a lot of their time. There is very little evidence for flying reindeer. But we have to remember the scientific principle that absence of evidence is not evidence of absence. Just because we haven't seen them fly doesn't mean they can't. So in this particular case, the jury is out. There's no conclusive evidence one way or the other. Okay, how fast would Santa and his sleigh have to fly in order to achieve the feats attributed to him? If he wants to visit 1 billion children in one night, and a night is about 36 hours, because of course he can take advantage of the different time zones as the Earth turns. So on average, the night time is about 12 hours. If he does it carefully from one side of the planet to the other, he should be able to do it in about 36 hours. If we assume that the children are distributed across the land masses of the planet, not strictly accurate, of course, there are some cities with very high densities of people and some areas with very low densities. Let's ignore that and just assume people are evenly spread over the land masses of the planet. Santa would have to travel at something like 2,000 kilometers per second. But that's tiny. That's only 0.007 of the speed of light, c. So in other words, moving at less than 1% of the speed of light, Santa is in no danger of defying the laws of physics regarding exceeding the speed of light. We know that no object can travel faster than light in a vacuum. Space can indeed expand faster than that, but that's a different matter. So in Fiat Lux, one of my talks, where I look at the nature of light, measuring the speed of light as well as measuring other aspects of light, that has been determined using a microwave oven to be about 300,000 kilometers per second. So 2,000 kilometers a second, or even faster, is in no way breaking any laws of physics, so that's fine. Aren't we likely to get roast reindeer? Wouldn't the sleigh and the reindeer burn up? Well, just as a meteor or an asteroid entering the Earth's atmosphere, if Santa is trying to move through the Earth's atmosphere very quickly, the air in front of the sleigh would be compressed and would heat up. Objects moving fast through the atmosphere don't get hot because of friction. That's a common misnomer. It's not friction, it's actually the compression of air that produces the heat. And we know that from our ABC of stellar evolution, because the ABC, one of the letters, the C, actually stands for compression produces heat. That's part of how stars work. So we know that an object moving fast through the atmosphere is likely to heat up. So maybe the sleigh needs to be very aerodynamic to make sure it can cope with that. But even if it was aerodynamic, that would still be a problem. So putting a few extra fenders on it and making it streamlined is not going to do that much good for us. So if it is going to get hot, wouldn't that make the sleigh glow white hot? Shouldn't Santa, moving extremely rapidly through the night sky, make the sleigh glow white hot? Well, we know that compression produces heat, and generally speaking, hot objects radiate light. If you take an object and heat it up, it becomes red hot. Heat it up more, it becomes white hot. So doesn't that mean Santa and the sleigh ought to be easily visible? Well, maybe it was. Okay, that was a long time ago, so if we bring that a little bit up to date, maybe it is. There's plenty of objects seen in the sky. Maybe some of those objects are indeed Santa and the sleigh. But if we think about a stealth sleigh, in other words, is it possible to make a sleigh that wouldn't be visible? What do we know about? What type of matter do we know about that does not emit or reflect light, or indeed any other type of electromagnetic waves? Well, that type of matter that doesn't interact in any way with light is what we call dark matter. So, presumably, if we never actually get to see a bright light in the sky on Christmas Eve, Santa and his sleigh, presumably, are made of dark matter. That's entirely feasible. It actually kills two birds with one stone, because not only does it explain why the sleigh doesn't glow, because dark matter doesn't emit light, so it wouldn't be visible. Dark matter doesn't absorb light or any electromagnetic radiation. It doesn't absorb radar either. So the sleigh would not show up on radar. Two birds with one stone. One explanation deals with two different facts, so must be true. Let's go back to the original claim. We've dealt with children, we've dealt with visits. Now let's have a think about actually what he does at the household. How on earth can Santa get down so many chimneys so quickly? If we're going to visit a billion children overnight, he would have to squeeze down thousands of chimneys each second. And remember, this is a portly, jolly fellow, so this particular individual is quite large compared to most chimneys. That's assuming we even have a chimney. deal with that in a second. But if Santa is very portly, how is he going to squeeze down a chimney? Well, in principle, there is a way that that could happen. When I talk about quantum mechanics in the talk, The Weird World of the Very, Very Small, I talk about atoms being made of a nucleus and a lot of electrons buzzing around. So there's no solidity, if you like, to an atom. It's a system like a beehive and a lot of bees buzzing around it. If you were to take those negatively charged electrons and swap them for a negatively charged muon, in other words, replace all of the electrons with muons, muons are like heavy electrons. They would actually make the atoms pretty much the same in terms of the electric charge, but all the atoms would be something like 200 times smaller. So if Santa was able to swap out all of his electrons for muons, then I'm not sure where he would get the muons from, but we're talking about what is possible, not what is easy to do. If he could swap all of his electrons with negatively charged muons, then he would instantly end up 200 times smaller and he would drop down a chimney, no problem at all. But as I've just said, yeah, that's fine if there's a chimney, but there's plenty of houses and apartments around the world that don't have chimneys. So, regardless of whether or not he could change his atomic makeup and slide down a chimney very easily, what is he going to do if there isn't a chimney? Well, actually, quantum mechanics comes to the rescue as well, because quantum mechanics tells us it is possible to go from outside an object to inside an object by passing through the walls or the doors. In other words, you don't have to open a window, you don't have to open a door. In the world of quantum mechanics, it is possible for an object to tunnel, this is the word that's used, tunnel through solid matter and arrive on the other side. This happens all the time with elementary particles. So if it's a known physical quantity, then why is it not plausible that Santa tunnels through from the outside of the house to the inside of a house and appears essentially instantaneously to be inside, having never actually passed through an open door or an open window? So that's allowed by the rules, the laws, if you like, of quantum mechanics. So that's fine, no problem at all. Let's go back to our statement one more time. We've thought about children numbers, we've thought about visits, we've thought about households. How can he do all of these things on Christmas Eve in one night? How can Santa make so many deliveries in one night? Even if he was travelling at relativistic speeds, how can you possibly do it all in 36 hours? Well, again, we're coming back to quantum mechanics. It looks like Santa must be a quantum mechanical being. Subatomic particles can be in two places at once. So, in other words, an electron can be over here, and simultaneously it can be over here at the same time. That is completely and totally allowed by the rules of quantum mechanics. You realise that quantum mechanics is so weird, we're starting to find explanations for a weird person like Santa. So if subatomic particles can be in two places at once, surely it's possible for Santa. Again, we're not quite sure how we would do that, but it doesn't actually break any laws of physics. If we don't like that explanation, if we say, no, that can't be right, if we insist that Santa can only be in one place at a time, then he would need a different way of making deliveries rather than relying on this quantum mechanical result. So what are the other options? Well, another option is Santa would have to find some way of manipulating space and time. I don't know how to do that, but just because I don't know how to do it doesn't mean Santa doesn't know how to do it. If you can distort space, we know that space can be distorted by, for instance, a very large gravitating body such as a sun or a black hole. We know that space and time are distorted or warped by large gravitating bodies. Maybe Santa has figured out a way of distorting space, bringing the places he wants to go closer together, or distorting time to allow him to travel effectively through time to make sure that he can do all of this in 36 hours. Again, I don't know how to do that, but just because I don't know how to do it doesn't mean it's impossible. It's allowed by the laws of physics. So we've thought about children and visits and households and how he can do everything on Christmas Eve. How can he do all of that and deliver the presents at least one present per child. How big does Santa's sack have to be? How could he possibly carry all the presents? One present for each of 1 billion children. How can the sleigh hold that much? Well, we come back to what we said before. If he's capable of changing space and time, then all he has to do is to make sure that the sack, or the sleigh, is bigger on the inside than it is on the outside. And that sounds like perhaps the TARDIS, but that's based on perfectly sound principles. It is possible for an object to be bigger on the inside than the outside. A black hole is an example. If you were to measure the circumference around the event horizon of a black hole, you find a particular measurement, but actually the black hole on the inside is larger than you would work out by measuring the circumference from the outside of the black hole. So the simplest way of saying that in English is the inside is bigger than the outside. So if that works for a black hole, why can't it work for Santa, who apparently is capable of distorting or warping space and time, and thus he can warp space to the point where he can make sure that his sack is a finite size on the outside but has a lot of space on the inside. Doesn't have to be that way. Again, we have an alternative. Isn't it amazing how we have more than one way of Santa doing what he is supposed to do? We don't have to make the sack bigger on the inside than the outside. An alternative is to say, well, let's temporarily store all of the presents in another dimension. As far as we know, there are only 3 dimensions of space, if you like, side to side, front to back, up and down. But there are plenty of people who think that space actually is made of more than 3 dimensions. We can only just see 3 of them. So maybe there are more dimensions, and maybe Santa knows how to access them. There may be more than 3, there may be a lot more than 3. If Santa has figured out how to move things between dimensions, then all he needs to do is to push all of the presents into another dimension, and then when he visits a given household, he just moves one present at a time back into the 3-dimensional spaces that we understand to deliver the present under the Christmas tree of the child. It's all very well saying that Santa might be able to do this, but wouldn't it need a huge amount of energy to either distort space and time or to do everything that we think he is capable of doing? Wouldn't it need a huge amount of energy? Santa plus a sleigh plus 1 billion presents moving at relativistic speeds would indeed need an incredible amount of energy. But we know from warping space and time that it is possible that a starship could be powered by a black hole. It wouldn't be a very large black hole. A black hole smaller than an atom would be enough to power a starship. So why couldn't it power a sleigh as well? The Hawking radiation from a small black hole, that's a huge amount of radiation. It would power a sleigh, and could it also power everything else that Santa wants to do? Alternatively, there's another energy source that we've overlooked and completely ignored up till now. The elephant in the room is what happens to all the mince pies? What if Santa could somehow convert the mass of all the mince pies that are left out for him into energy? E equals mc squared. Would that be enough energy for him to use? Let's do a little bit of maths. Look away now if you don't like numbers. 1 mince pie, E equals mc squared, mass times the speed of light squared. What's the mass of a mince pie? It's about 50 grams or so. Speed of light is 3 times 10 to the 8 meters per second, and therefore c squared is about 10 to the 17 or so. That gives you 1 mince pie, if converted into energy, is about 5 times 10 to the power 15 joules. Joules is the standard SI unit of energy. If you don't like joules, just think of it as it's a bit like a calorie. It doesn't matter, it's a little different from a calorie, but not by much. So that's how much 1 mince pie gives you. If a few percent of households leave a mince pie for Santa, some might leave cookies or biscuits or other things. Let's assume that they all have a similar calorific value, and let's do the calculation for that. Santa might eat some of the mince pies, but he'd be crazy if he ate too many. Let's assume a few percent of households leave out a mince pie and Santa can tap into that mass. 20 million mince pies, let's just pick a number out of thin air, that would give you how much energy? If one mince pie is 5 times 10 to the 15, then multiply that by 20 million, you end up with a total energy of 10 to the power 23 joules. And I'm sure that means nothing to you because you have nothing to relate that to. So let me tell you how much energy that is. That is the energy equivalent to the output of a nuclear power station running for 1 million years. That is how much energy Santa has available if he could convert the mince pies from mass to energy. How do you extract E equals mc squared from a mince pie? Well, if you've got a large number of mince pies, all you need to do is to find an equivalent number of anti-mince pies and collide them together. And kaboom, if you have a large mince pie collider, for instance like the one at CERN, then you can actually bang these together and get a huge amount of energy out. But of course that begs the question, well, where do you get the anti-mince pies from? So maybe that's a non-starter. There has to be a different way of extracting energy from mass. And luckily there is. An alternative way, you don't necessarily get all of E equals mc squared out of a given amount of mass, but one way of extracting most of E equals mc squared from a given mass is to do the following. Drop it into a black hole. Dropping matter into a black hole is a very efficient way of converting matter into energy. In my talk Ancient Light, I talked about a quasar. And matter falling into a black hole can produce a quasar. The matter, which is probably not mince pies in the case of a quasar, is converted into energy in the form of radiation. And in the case of a quasar, the light from that quasar can be seen even if the quasar is at a distance of 25 billion light years. So matter falling into a black hole is a very efficient way of generating energy. So if Santa does have a black hole powering his sleigh, then all he has to do is to drop the mince pies into it and he gets a huge amount of energy out. Also, by convenience, the black hole gets a little bit bigger as well because of the mass that's being dropped into the black hole. So again, it's a win-win scenario. You actually gain more fuel for your black hole as well as some of the fuel being converted into energy which you then use for your other tasks. How much energy could you release by dropping mince pies into a black hole? I cannot find any research papers on this topic. I can't find any reports of studies of mince pies being dropped into black holes. So I don't actually know the numbers, but I assume it's a big number and more than enough for Santa's needs. How could Santa do all that? It's all very well saying he hasn't broken any laws of physics, and if he distorts space or takes all of the mince pies and drops them in a black hole, how could he possibly do all that? They might be possible, but how could we imagine, for instance, Santa being able to manipulate space and time? Well, one thing we're overlooking is who says he's human? Perhaps the jolly individual might not be human. Who says he hasn't got green skin and big ears? So we have to bear that in mind. So when we return to the original question, right, how many laws of physics does Santa break? The answer, I believe, is none at all. So feel free to draw your own conclusions about the existence or otherwise of the portly, jolly fellow with the white beard and a penchant for wearing red suits. Regardless of your conclusion, I'd like to wish you all a Merry Christmas. Thank you for listening.